everybody. So in this video, we're going to look at circles and chords. So in example 1, we're told that the points A and B with coordinates 5, 5, which is point A, and 1, -7, point B, lie on the circle with equation x squared plus y squared equals 50. That's this circle here. To begin with, for part A, we've been asked to find the gradient of a line L1. So if we look at the line segment between A to B, and we sketch this out separately, we know that A is at point 5, 5, B is at point 1, -7. So we can work out the gradient of this line segment by finding the change in x, which is the distance from 1 to 5, so 4, and the change in y, which is the distance between 5 to -7. So this is 12. So the gradient of A to B, m, will be the change in y divided by the change in x. Change in y we've just worked out as 12, and the change in x we know is 4. So the gradient of this line segment will be 3. Part B, we're told that L2 is the perpendicular bisector of the chord AB, and we've been asked to work out the equation of a line L2, which is this green line here. So because it's a perpendicular bisector, we know L2 will cut this line segment exactly halfway and at 90 degrees. So because it cuts at 90 degrees, we know the gradient of L2 will be the negative reciprocal of the gradient of L1. So we know the gradient of L2 will be -1/3. Now we can use the equation of a line to work out L2. We'll have -1/3 multiplied by x minus x1 will equal y minus y1, where x1 and y1 is a known point on this green line. So we need to work out a point on this line, and we can do this by working out this point, because this is the midpoint of A to B. So if we look at the midpoint of A to B, well, we can work out the x value by finding the average of the two known x values. This will be 5 plus 1 over 2. So the x value will be 3. And the y value will be the average of the two known y values. So the average of 5 and -7. So 5 plus -7 becomes 5 take away 7, divided by 2. This will be -1. Now we've got a point on the line. It'll be at 3 and -1. And we can substitute these values into our equation of a line. So we'll put 3 here, and y take away -1 becomes y plus 1. So now we can tidy this up by moving this division of 3 to the right-hand side of our equation, and then we'll expand out these brackets. So we get -x plus 3 will equal 3y plus 3. We can take away 3 from both sides, so -x will equal 3y, or therefore y will equal -1/3 of x. Okay, so that's the equation of this line L2. And then for part C, show that L2 passes through the centre of a circle. So we have the equation of a circle given here, x squared plus y squared equals 50. And from the equation of a circle, we know that our a value must be 0, our b value must also be 0. So the centre of this circle will be at 0, 0, or just the origin. And we also know from the equation of line L2, because it has 0 intercept, when y equals 0, x will be equal to -1/3 of 0, so 0. So we've shown that this line passes through the centre of a circle. Okay?